In this video, students, we are going to discuss or explain the solution for the revision sheet for the final exams, grade 8. Exercise 1, fill in the blanks with the appropriate words. A motion is said to be periodic if it repeats itself identically in equal intervals of time. When we say identically, that means in the same manner, in the same way. And in equal intervals of time, يعني it needs the same duration. For example, when the pendulum vibrates, starting from a certain initial position, it goes and comes back to its initial position within 5 seconds. Then it goes and comes back within another 5 seconds, goes and comes back 5 seconds. So it's repeating itself identically with equal intervals of time. Periodic motion is not always vibratory. Could be like the rotation of Earth around the Sun. It's also considered to be periodic motion because also to complete one whole rotation, the Earth needs 365 days. So this is repeated every year. So this is also considered to be periodic because it repeats itself identically in equal intervals of time. Now, concerning number 2, a vibratory motion is a to and a fro motion is a to starting from going to a certain position and then going back to the position from which it started. So it's a to and a fro motion between two extreme positions. A mechanical wave, 3. A mechanical wave is a disturbance or perturbation, both are correct, that propagates in a medium carrying energy. As long as it is propagating, this means it needs energy or it carries energy, but it doesn't carry the particles of the medium, like the mechanical wave example, the ocean wave or sea wave. It's a disturbance that propagates through the water but doesn't move the water from one part to another. Otherwise, we would have sometimes our sea empty of water and other times flowing extremely. So no, the water doesn't move from one place to another. It remains in its place. Only the perturbation passes through the medium, causing the particles to vibrate like upwards and downwards and then become stable after a while. For exercise 2, the mechanical wave propagates at a speed of 4 meters per second along a string. So the figure below represents the aspect of the string at a given instant. Indicate whether the considered wave is transverse or longitudinal wave. It's clear that it is transverse because the wave is propagating from left to right, horizontally. And as you can see here, if this is considered to be the string, the particles of the string, if we choose this particle, it's going to, it was initially at this equilibrium position. As the perturbation or as the mechanical wave passed through it, it vibrated up, then it's going to come back down, and then finally after a certain while, after vibrating, it will again retain its equilibrium position. Number 2, determine graphically the wavelength lambda and the amplitude A of this wave. So if you go back to the notes, the wavelength is considered to be, as a definition, it's the distance covered by the wave during one cycle. And how can we determine it graphically? There are 3 ways, either by measuring the distance between 2 consecutive crests, or between 2 consecutive troughs, or between corresponding or identical positions on the equilibrium position. So either between showing one whole cycle, this is the whole cycle, so between this point and this point, these are consecutive crests or consecutive troughs, so all are going to give the same value. If I consider these 2 consecutive crests, the first one is at 5 centimeters away from the origin, and the other one is 15 centimeters away from the origin. So the distance between them, in order, is lambda. In order to calculate it, we have to subtract 15 centimeters minus 5 centimeters, it's 10 centimeters. And the amplitude is the maximum displacement of this string with respect to the equilibrium position. So it is here 1 centimeter given. Now part 3, calculate the time required for the wave to travel the distance lambda. Most of you maybe thought of simply saying to travel distance lambda means to cover one cycle and it's the period, but in this way we want it indirectly.